Alright, we're going to go ahead and get started with Lecture 2 of our Unit 1, Measurements and Uncertainties. In this particular lecture, we are going to focus our attention on significant figures. Alright, so when we're done with this particular lecture, we need to be able to answer the essential question, why are significant figures so significant? So when you've viewed this lecture and are finished with it, please return back to this essential question and make sure that you can answer it for the quiz that we will be having. Alright, in our last lecture we addressed experimental error, both systematic error and random error. In this particular lecture we're going to focus on more or less random error and significant figures that deal with that. So first of all, random error, if you remember, exists in every measurement. This is because there are limitations in every instrument that you use to measure something. A limitation in the instrument is going to affect the instrument's precision, or the number of possible digits that can be recorded for that measurement. Now, the possible digits that can be recorded for any measurement are known as significant figures, or we usually just call them sig figs for short. Now, each measurement includes all the certain digits that everyone will agree on. And now this is really important, so make sure that you either highlight this or underline it, but make sure you learn it. Again, each measurement includes all the certain digits that everyone agrees on and one uncertain or estimated digit. And it doesn't matter what kind of measurement it is, you must always include the certain digits, the ones we know for sure and agree upon, plus one estimated digit. Now these digits make up a measurement's significant figures. Alright, let's take an example here and see if we can figure out the correct number of significant figures in the measurement of this graduated cylinder. So if we look closely at the graduated cylinder, and it's been enlarged here, you will notice that our liquid level lies between 15 and 20. So why don't you take a moment and see if you can figure out, write down what you believe this measurement to be. Go ahead and pause the lecture. Alright, so we know then that there should be two digits that we all agree on, and that's 1 and 7. And that's because you have 15, 16, 17. But we also know that the liquid level is going to be below 18. So it has to become, our final measurement must be between 17 and 18. Now, that means our last digit, which we are not sure about, has to be estimated. So I might estimate 17. 17 point, I'm going to say 8. Okay. Now, somebody else in the class, and even yourself, might have maybe said 17.7. Some of you might have even said 17.6. But every one of us, no matter what, should agree on the 1 and the 7, or the 17. It is this last column, our estimated column, that's going to be varied. and this is known as our uncertainty. So in this particular instance, with this measurement, we can only have 3 significant figures that can be reported in my answer. Our 2 certain digits, the 1 and the 7, and our 1 estimated digit. Alright, so here's another one. Here we have a ruler that's measuring a stick here, we'll say, or a rod of some sort. And it looks like our measurement lies somewhere around here. Okay, so let's see. Go ahead and pause this for a minute and see if you can figure out what that measurement might be. Okay, so I know that we have, this is our 1, this would be our 2, and so we know our measurement lies between 1 and 2. So let's see if we can count this. So we have, this is 1, 2, 3, 4, 5, 6. So we know it's got to be at least 1.6. Those are our certain digits. But our next digit is going to have to be estimated. And I'm going to go ahead and estimate that as 1.67. And these are probably inches. So I'll put that unit in there. Now you might disagree with that last digit, and that's okay. So you might say it's 1.68 maybe. And that's fine, because as long as we agree on the 1 and the 6, but disagree in our last column, which is our estimated digit, then we're okay. Now, again then, our measurement indicates that we can have 3 sig figs in our measurement. Alright, here we have another graduated cylinder. Go ahead and pause the lecture here and see if you can determine what the measurement of the liquid volume in the graduated cylinder is. Alright, so we know we have the 50 milliliter mark is right here, and the 60 milliliter mark is here. So it looks like we're going to go up by ones here. So we have, this is going to be 51, 52, and it looks like 53 is here, so the liquid level is just below 53. So I'm going to say that it's 52.9 milliliters. Alright. Now, you might have said it was 52.8 milliliters, and that's okay. We should definitely agree on the 5 and the 2, because those should be certain digits. But again, that last digit is going to be our estimated digit, and so we may not agree on that. And that's okay, because that's what significant figures is all about. It includes all our certain ones plus our 1 estimated digit. So again, how many significant figures can our measurement have? Well, that would be 3 sig figs again. Okay, so now that we have that, let's summarize here with this. Remember, the last digit of any measured quantity is uncertain and must be estimated. All digits, including the uncertain one, are called significant digits, or more commonly significant figures. Alright, now there's some simple rules that you need to follow when writing out or determining correct number of significant figures. The biggest thing when it comes to writing significant figures or identifying how many significant figures are in a measurement is the zeros. Zeros can be a problem because sometimes zeros are significant and other times they're just placeholders and therefore they're not significant. So we have to look at zeros and decide, are they just placeholders or are they actual significant digits? So these rules will help us to understand what to do with zeros. So first of all, rule number 1 states that all non-zero digits are significant. For example, 1, 2, 3 grams has 3 significant digits. All of these are non-zero digits, so they must be significant. Another example would be 1.677. Because all these digits are non-zero digits, all 4 of them are significant. So this would have 4 sig figs in my answer. Alright? So rule number 1 is pretty simple. Okay, let's erase this. And let's take a look at rule number 2. Rule number 2 says if zeros precede the first non-zero digit, they are not significant. For example, if you had a number of 0.00012 meters, it will only have 2 significant figures. That's because these zeros right here are not significant. So anytime zeros come before a number, they are never, ever significant. The same thing with our next example of 0.01. This number only has 1 significant digit because the zeros at the beginning of the number are never significant. So what exactly do these zeros indicate? Well, they're just placeholders. That is it. That's all they are. Okay, so let's look at another possible example. If you had 0.000234, alright? Now, in this case, you have 3 zeros that come before the 2. Therefore, the zeros coming before that 2 are not significant. They are just placeholders. So we do not consider them significant. Instead, only the 2, 3, and 4 are significant. So this number has only 3 significant figures. Alright. Now, let's go ahead into rule number 3 here. Rule number 3 is pretty easy to understand. If zeros are between non-zero digits, they are significant, always. For example, you have 40.103 kilograms. The 0 between the 4 and the 1 is significant, just as the 0 between the 1 and the 3 is significant. So in this case, all the zeros are significant, and therefore we have 5 significant figures. Alright, here's the other example. You have 0.0503. Well, the first 2 zeros come before the number, so they're not significant at all. So we cross those out. But the other 0 comes between a 5 and a 3. Therefore, this 0 here is significant. And we have 3 significant figures in my answer. Let me give you another one. So if I have 0.003201, how many significant figures do we have? Well, the first 3 zeros are not significant because they come before the number. But the 0 in between the 2 and the 1 would be considered significant. So in this case, we should have a total of 4 sig figs. All four of them are significant. Alright, now we're going to look at our very last rule on significant figures. If the zeros follow non-zero digits, they are significant only if a decimal point is there. Okay, so decimal point must be in the number in order for zeros to be significant at an end of a number. So for instance, we have in our example 400 with a decimal point milliliters. These zeros come at the end of the number. They are only significant because there's a decimal point there. Therefore, we have 3 sig figs in this number. However, if we had 400 milliliters and there was no decimal point in the number, these zeros are not significant and there would only be one significant figure in my answer. Alright, let's take a look at some others. Let me erase this. This last rule is sometimes confusing the first time you view significant figures. So let me do some other ones. For example, let us say we have 0.01420. Alright? Now, we have 3 zeros. The first 2 zeros are not significant because they come before the number. But what about this last zero? Well, according to the rule, it says that a zero at the end of the number, which this zero is, will only be significant if there's a decimal point somewhere in the number. And there is. We have a decimal point right here. So therefore, that makes this zero significant. So we would say that we have 4 significant figures. The 1, 4, 2, and 0 are all significant. Alright, let's get some other ones here. Alright, we got a number of 40.00. Alright, we have 3 zeros. Are they significant? Well, these zeros come at the very end of the number. Are they significant? The answer is yes, because there is, that's right, a decimal point in the number. Therefore, all 3 of the zeros are significant. Alright, hopefully this will help. We're going to do some more practice here in just a minute here. Alright, there are 2 other major rules of significant figures. Both of them deal with when we add, subtract, multiply, or divide measurements to get our final number of significant figures. Now, these are going to take some time to really fully comprehend and understand. So what we're going to do is spend some time in class going over rules 5 and 6. So we're going to hold off on them until class. However, what we are going to do is we're going to practice right now rules number 1 through 4 and see if you can be able to determine the number of significant figures in these numbers. So here we go. The first one is this. We got, we have 4.6070. Alright? Now, how many significant figures are in this number? Go ahead and pause this tutorial for a minute and see if you can come up with an answer. Alright, did you say that there was 1, 2, 3, 4, 5 significant figures? 5 sig figs should be in this answer. Now why? Well, first of all, the 4, 6, and 7 are non-zero digits, so according to rule number 1, they are significant. Now what about the 2 zeros? Well, the first 0 comes between the 6 and the 7, so therefore that 0 must be significant. The last 0 comes at the end of the number, and because there is a decimal point in the number, that 0 also is significant. Therefore, we have 5 significant figures total. Alright, let's look at another one. What if I have 0.0035000 milliliters? Right? Go ahead and take some time and figure out how many significant figures there are in this measurement. Alright, if you said that there are 4 significant figures, you would be correct. The 3 and the 5 are significant because they're non-zero. The zeros at the beginning of the number are not significant. The zeros at the end of the number are because there is a decimal point, giving us with 4 significant figures. Alright, let's look at another one. Let me erase these. Let's see what we can do here. Alright, let's take a number of 40. Right? How many significant figures are in the number 40 grams? That's right. There's only one sig fig. The 4 is significant because it's a non-zero digit, but the last 0 is not significant. Why? Because there's no decimal point in the number, so that 0 cannot be significant. Let's take another example. If I have 6,000 milliliters, are the zeros significant? The answer would be no. Why are these zeros not significant? Because there is no decimal point in the number. However, if I would have said 6,000 and I would have included a decimal point, then all 3 of those zeros would have been significant because they come at the end of the number and there is a decimal point. So in this case, there would be 4 significant figures for this number, but only 1 sig fig for the 6,000 with no decimal points. Alright, are we starting to feel more comfortable with the rules of significant figures? Maybe let's look a little bit more detail into this. Let's look at the number 500. Alright, so I'm going to write that down. Here's 500. Alright, now notice that there is no decimal place in my answer, so therefore I only have one significant figure, and that would be the 5. Those other zeros are not significant, but they're still included because they're considered placeholders in my number. So where exactly is my uncertainty? What is my estimated digit? Well, it turns out it is the 5. The 5 is my only significant figure, therefore it must be an estimated number, and the zeros have no meaning. They are just simply placeholders. However, if I use the number 500 and add a decimal point in my answer, because I have that decimal point, all 3 are significant. So where is my estimated digit? If you guessed the last zero, you would be correct. That last zero is significant. Therefore, since it's the last number, it is my estimated number. Therefore, the 5 and the 0 are exact numbers, the numbers that we agree on. Okay? Now, let's try the number 30. There is no decimal point. Therefore, the 0 is not significant, only the 3 is. So the 3 is my estimated digit, not the 0. The 0 is just what? It's a placeholder. Now, if I would have added a decimal point, though, at the end of 30, then my estimated digit would be, you guessed it, the 0. The 0 is my last significant figure. It must be the estimated digit. And then the 3 is going to be my certain digit, the one that we're all going to agree on. Alright, so I'm hoping you're starting to get this and understand the significant figure rules. If you're still having some problems, I would go back, review this tutorial again, and relook at the examples and practice. You can also try some on your own and see what you can come up with. Alright, so the last two rules, if you remember, 5 and 6, deal with multiplication, division, adding, and subtraction, and we're going to deal with those in class. So hold off on those rules for right now. Alright, this is all for this for lecture 2, and we will see you. Have a good day. Enjoy chemistry.